Hi out there. I hope you're doing well on this beautiful day. So today, guys, what we'd like to explore is using statistic to make decision. Okay. So my name is Rakubu. I'll be taking you through how we can use statistics to use decision. Arrive at some conclusion. Great. Let's see what we have. But before we do that, what I'd like you to do, how do we really make decisions on a daily basis in your own life? Have you ever thought about it? Do you make decisions based on what your friends think, what they think at home? How do we really make decisions? Sometimes, yes, we might use history and say, oh, yes, I remember this because of this and this. That's actually using data when you make decisions that way. But big corporation and government, we make decisions by collecting data, analyzing data, and arrive at some conclusion. That's another form of decision. How do you use decision on your own? Think about it. Do you just randomly make decisions? Okay, let's see. So now let's define what is volatility. And how do we really measure volatility? What is volatility? Volatility is actually risk, or you might have had this, usually in finance or from stock market, they'll talk about volatility. It's randomness. It's if, let's say, the rand. Today the rand is 15 rand to $1. Suddenly it changed to 17, 18, all the way, and it changes rapidly. We'll say the rand is volatile, okay, because it's deviating a lot from average over a period of time. It can be daily, can be within an hour, just moving, okay. And we do have commodities which are volatile. Some of them are things like oil. They're very volatile. You know, the price is not that fixed. You might know the price is, let's say, 100 rand now, but tomorrow when you check the price, changed. You check within an hour, the price has changed. That's volatility. Okay, it's a high deviation from the average. And how do we measure volatility? Volatility, we're talking about the deviation from the average. Okay. So another way we can measure volatility is by using the standard deviation. And remember, standard deviation is the average, but it's a special average, which is the average deviation from the mean, which is the average. Okay. Remember, let's say I have your marks in a class. Student, you got 30%, 40%, 60%, and so on. And the average for the class is 55%. Then, how far are you from the average? That's the standard deviation. Does that make sense? If the class average is 55% and your mark is 60%, you're 5% deviated from the average. You're above by 5%. Okay. So standard deviation is all those deviations for each and every learner in that class. Are we all together? Fantastic. So now, what I'd like us, we're looking at decision making, and we're going to look at problem favorite crisps flavor. We'll solve that, and smoking among young people, and we'll look at an investment problem. After an investment problem, we'll look at performance between two classes. Okay. And decision making, guys, you can actually study, which is a new thing, called decision science or operation research. And actually, there's lots of study that actually World War II was won by decision science. By optimizing resources. Okay, so some countries will optimize resources during World War II to win the war. Actually, there's a loss that World War II was won by using decisions. Okay, so decision science, it's a big field which you can study, also known as operation research. Okay, so we'll look at also at the projection, the number of coronavirus deaths in South Africa. Okay, so what is decision and what is statistics? I mean, for me, decision might involve a bit of thinking about what available options, and from available options, you choose one. I might want to buy banana or apple, and you make a decision and say, based on what? So sometimes it might be based on cost, even though you want it. But finances might force you to take that kind of decision. Doesn't mean what we want. Sometimes circumstances will force us to make that kind of decision. Okay, but now in statistics, when we make decision, we try to, we'll look at mean, average, all those kind of things, and arrive at some conclusion based on that. Okay, that's another form of making decision. Then, what is statistics? Statistics is a study of analyzing data and representing data also. And from there, we still arrive at conclusion. It's the same as decision, but made using statistics and data. Okay. So the two are kind of related in a way. Now, what are we going? Let's look at some of the keywords, which is volatility and return. So volatility, it's a low volatility, it's a lower deviation from the average. You know, the movement is not that rapid, but where volatility is high, the movement is rapid in a way. Okay, I'm not sure if you've seen the stock market. If you look at those graphs, the more they like movement, the volatility is high, and the less noise, the less the volatility. And what is return? When you talk about return, okay, and I'll use that where we look at an example in investment. Return, we're talking about when you invest money and you earn interest, you make a return on your investment. Okay, that's what we're talking about. So let's start. We said we'll look at the favorite crisp flavors, smoking among young people, investments, performance between classes, and the projection, the number of coronavirus deaths. Let's look at that. Now let's start. Which age group are at greater risk of requiring hospitalization or dying if they are diagnosed with COVID-19? Can we calculate the average age of people at high risk? Can we calculate the people at high risk from dying from COVID-19 or being in hospital? Okay. Let's look at how we can calculate that and then arrive to some conclusion. So, this is the actual data collected. And if you look at this data, it's grouped data. So if you look at this, this is number of deaths from there. So what does this indicate? The graph showing number of coronavirus deaths in South Africa in 2020 by age. 0 to 9 years, only 3. This does not mean the whole year, but this implies maybe it was a week or 2 weeks or probably a month. Okay. 0 to 9, we had 3. 10 to 19, 5 deaths. And 20 to 29, 26. 30 to 39, 116. 40 to 49, 244. And we can see that 50 to 59, which is 471. And 60 to 69, 506. Can you see that 60 to 69, that's the highest? Okay, those are where we get most of our death from COVID-19. So we'll call that a modal class. It's a mode, the most occurring. So that will be the modal class. This will be our modal class. Then you go to 70 to 79, it's about 342, 80 to 89, 161, and 90 to 99, which is 45, unknown 11. What does it mean? Unknown, we don't know their age, okay? How does that happen? How can we not know? We know that 11 people died from COVID-19, but we know their age. We don't know their age. It's possible that they were in the hospital and no identification or something like of that nature. But we still have the statistics for that. And this is the total people died from the COVID-19 for that period. How do we calculate the average? We're going to take this grouped data and put in the what? Frequency table. And remember that the frequency table will put the age, the frequency. Frequency will be how many people die from COVID-19 per class interval. And when you talk about class interval, we're talking about the age category, which is 0 to 9, 10 to 19, and so on. Let's do that and see how it looks like. We're going to take this, put it in the frequency table. So, which age group are at greater risk of requiring hospitalization or dying if they are diagnosed with COVID-19? We can calculate the average age of people at risk. Let's see. How are we going to estimate the average? Because if you look at the table which was published by the government, I think, we don't have the raw data. What do we mean raw data? The actual age, we just have the groups that between 0 and 9 is only 3. So we'll have to calculate an estimated mean. Are we together? Using the data. Okay. So to do that, an estimated for the mean can be obtained by assuming that each of the raw data takes the midpoint values of the interval in which it has been placed. For example, to calculate the mean, it will be the sum of all frequency, are we all together, multiplied by the midpoint over the total number of frequency, which is that mathematical, which is F times X. X is the midpoint, F is the frequency, and this is the frequency which is over the total frequency. Okay. So what are we going to do? We want to know how many people died in each age group interval, which is the frequency. Then find the midpoint. The midpoint is halfway of the age interval. Multiply by the frequency. Then from there, we'll calculate the mean. Okay. So for now, we're going to take a short break. When we come back, we'll do the actual calculation. Then let's make decisions from there. I hope out there, guys, you're not just observing only. You need a pen and paper to do your mathematics, okay? And remember, never give up. And it's okay not to understand. We just have to persist and put effort. It's okay when I look at a problem and I say, I have no idea. What is important is what we do when you don't understand. I think it's to seek help, and it's to keep working hard and being consistent. That's the most powerful thing. Great. See you after the break where we do the actual calculation. Hello out there. Welcome back once again. Hope you're ready to push with us. Let me remind you, what are we trying to calculate? Why are we calculating? To make decisions, to make some conclusion. So we want to calculate the age category which is at high risk for being hospitalized or dying from the COVID-19. Okay. So we have grouped data and said to calculate the mean or the average, it'll be an estimated mean because we don't have the actual raw data. Let's see how we do this. Okay. So this is the table, actual table. Let me explain this again. So the age of 0 to 9, we have 3. Frequency implies 3 people, young people between the age of 0 and 9 died from COVID-19. Are we together? Then we find the midpoint. The midpoint is 0.5. How did we do this? 0 plus 9 divided by 2, that gives us 4.5. Are we together? So we divide 9 plus 0 divided by 2, we get 4.5, which is the midpoint of that class interval. Then from there, we're going to say midpoint times the frequency. So the frequency is how many data set in that interval, which is 3 multiplied by 4.5, which is give us 13.5. And we do this for each and every age group from the age of 10 to 19. We do the same. The frequency is 5, meaning 5 people between the age of 10 to 19 died from COVID-19. The midpoint is 14.5. Are we together? Then we multiply, that's what we get. So we do the whole thing for all the way from, we do similarly with that. Those are the frequency, we find the midpoint for that. One midpoint for that, which is that. Then we multiply, we get midpoint times the frequency. That's what we get. Then the frequency for 22 to 39 is 116. 116 people died from the COVID-19. Now we add the total frequency, all the frequency. If you add all the frequency, which gives us 1919, that is the total number of people died from COVID-19 if we add everything. Remember, this is not the whole year. It was 2 weeks, probably 3 weeks, or a month of data collection. Then from there, we're going to add all this. Remember how I got this? It's midpoint times frequencies. Yes. This time this, you're multiplying those. This time this, you get that. So we add all this, and this is what we get. So what does that mean? Now the mean, it will be what? This over that. Okay, let's see. So the mean, we're adding all what? This is what we're adding. If you go back, show you. This is what you're adding, all that. If you add that, this is what we're adding over the total frequency. So what we're doing here is sum midpoint times x over the sum of frequency, which is x bar. Remember, x bar is the same as the mean. What do we get? We're getting, if you add this total, the total on top, that's what we get, divided by the total, and we get 60.78. That's an average age of dying from COVID-19. Does it mean COVID-19 will affect people at 60 years? Not really. Even if you're young, you can still die from COVID-19. But what it means is that the risk of you being hospitalized or dying from that, it's lower. But does not mean you cannot die from COVID-19 or be hospitalized because of your age. The data just says, on average, that's the age that might die from COVID-19 or be hospitalized. Okay, very, very, very important how we interpret the data. Okay, now let's see what it means. All the adults are at greater risk of acquiring hospitalization or dying if they're diagnosed with COVID-19. As you get older, your risk of being hospitalized with COVID-19 increases from statistics. This is very important. I mean, this has been published there. 8 out of 10 COVID-19 deaths reported in the US have been in adults 65 years older and older. That's very important. Can you see? Very close to the average we're getting in South Africa, where United States, it's above the age of 65. Similarly, so the data, if we compare with other countries, we get some similarity. So it implies when you analyze data, sometimes what does the international counterpart variable look like before we make some decision? So we're very close to that 65 they have. Okay. This is what I was talking about. So what it means, it doesn't mean because you're young, you cannot be hospitalized. It implies the risk is lower, but you can be. So let's look at this. For example, the age of 30 to 39, being hospitalized is the hospitalization is 2 times higher. Death, 4 times higher. But the age of 40 to 49 is 3 times higher, but death 10 times higher. So we can see that between the age of 65 to 74, hospitalization is 5 times higher and death 90 times higher if we compare. And the higher risk, which is actually 85 above, if you look at the death, is 330 higher, the chance of dying from there. Okay, very important. Because you're young, you cannot be affected by COVID-19, can affect you, and you can really die from COVID-19. It just implies the risk, it's lower for you. Okay, fantastic. Now, what are we going to do now? We're going to look at, which is smoking among young people, okay? I mean, do we really have young people smoking? I mean, this is the actual data collected of young people smoking. And actually, you shouldn't be smoking at all. Okay? Shouldn't be completely. It's bad for you. Okay. So let's look at that. So the table shows the percentage of age 11 that smoke regularly. The age of 11 that smokes. Sure. Yeah. Let's see what it looks like. So we're going to compare. So this is a case study. So the data is from 1982 all the way to 2002. So in 1982, you can see 24% boys smoking and about 25% of girls. 1984, you can see 28% boys smoking, girls still 28%. If you look at 2000, if I look at the table, we have about 21% boys smoking and 26%. So we can represent this data using a line graph. Why do you want to use a line graph? Do you want to see, is the smoking among young people going down or increasing? Because actually we want to decrease it. We don't want that to increase. Is that increasing or decreasing? Let's see what it looks like. So we can use line graph. If you look at the blue, it's boys. And the pink is the girls. So you can see in what does that tell us? In 1984, the numbers of girls and boys smoking, the percentage was the same. And from there, the number of boys decreases that actually smoking. Even the girls decrease, but slightly, where boys really increase at higher rate. What might be the reason? Be interesting. Both decreased. Okay. Then also there where they do meet implies they were equal. Okay. Then we can see that the boys there increased. Okay. Girls increased. Boys also increased. So actually both they increase and decrease same time. Interesting. 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 So how does the trend in smoking for young people compare to the regular older smoker? So now let's look at all the people who are smoking. So if you look at the trend for young people, just increasing, decreasing, increasing, decreasing, then flat at the end. There's no increase. But let's look at the older people. How does this compare to the older? This is the old. So it's also increasing, then decrease, increase, slightly decrease, increase, then a bit flat at the end. So if you look at them, there they are, the two line graph similarly. Okay. What does this mean? I mean, there's the same pattern between young people and older girls. But we can see that the boys started with this high number, similar to the girls, but now we have less and less boys smoking at the age of 11. Similarly, among all the people, we have less and less people smoking. Even among girls. But we still have lots of girls smoking compared to boys. Are we together? Okay. So guys, now we're going to take a break, a short break. And when we come back, we're going to look at another problem. We're going to look at a problem in finance, in an investment. How do we make decision in investment and arrive at conclusion? Okay, so we're going to use those terminology defined at the beginning: volatility, risk, and return. Because what do we want to do? We want to make high return and avoid risk. How do we do that using statistics? Join us after the break, and we're going to think about that. See you shortly. Hello there guys, welcome back once again. We're still on making decisions using statistics, okay? So we looked at a problem where we calculate the average age of dying from COVID-19 and we concluded that it doesn't mean if you more than the age of 60 only, but even young people, just the risk of being hospitalized or dying from that is lower. It's an interesting problem we solve using data and arriving at some conclusion. Then the second problem was the smoking amongst young people. Okay, so we can see that it's really decreased, which is a good news, and we hope now it's actually decreased more compared to the year 2002. Now what we're going to look at is a problem in an investment. How can we use statistics to make decisions in finance? Let's see what we have. So we're going to look at investments. So there is a question. A hedge fund manager plans to invest a certain amount of money every month. One of the three funds which they have shortlisted for investments. Okay. So if the hedge fund managers wishes to avoid volatility, remember volatility, we're talking about risk. There is no free lunch. There will be a risk. But we want to reduce the chances of losing the funds. Are we all together? Okay. So what does hedge fund manager mean? Have you heard of the word hedge fund? A hedge fund manager, your parents or people you know that they might be investing money for retirement. And a hedge fund, hedge is to, like a hedgehog, the animal hedgehog. If a hedgehog is being attacked, it rolls into a ball, it's protect. So it comes from the word hedgehog, to hedge, to protect your money, to reduce the risk. So a hedge fund manager will take money from different people, different corporations, and invest it and grow that money so that maybe when you retire, you have enough money. So that's what a hedge fund manager do. So they'll calculate the risk and make decisions. Some of the decisions will be based on statistics. Let's look at how we can make a decision for this kind of hedge fund manager. So let's see what we have. So here we have returns for the last 5 years given. Returns is like think of that as a performance of a bank each and every year. So we have Bank A. Year 1, their return was 10%. Whatever they invested, they made 10%. Year 2, they just made 6%. Year 3, only 3%, which they managed to make on whatever they have. Then year 4, 9%. Year 5 was similar to 9%. Then the second bank, which is shortlisted by the hedge fund manager, they made a 5%, a 10%, 9%, 8%, and 5%. Bank C, which is 6%, 7%, 6, 7, and 15. Bank C looks lucrative based on 15. But is that the best? On year 5, outperformed Bank 2, Bank B by 10% and outperformed the first bank by 6%. But we can't really predict, what will have happened in year 5. So let's see. What statistic tool should we use? Let's see. One is the measure of dispersion. Remember that the measure of dispersion is how the data is spread out. There are 3 commonly used measures of dispersion, which is the range, interquartile range, and the standard deviation. And remember that the range is the maximum minus the minimum, which gives us the range. Are we together? Then the interquartile range is Q3 minus Q2, meaningly the upper quartile minus the lower quartile. Are we together? What is different between the range and the interquartile range? The range can be what? Can be affected by the extreme values, the high and the lows. Where the interquartile range cannot, because it's in between, it uses 50% of the data in the middle, cannot be affected by the interquartile range. The standard deviation, which is actually one of the good ones, it uses all the data, which is the average deviation from the average. Are we together? So now let's see. So let's talk about that. If the scores are spread out, then the range will be higher and the score less consistent. Okay? If the scores are close together, then the range will be lower and the score will be more consistent. And we know that the range is the maximum value minus the minimum value. Are we together? The highest minus the lowest. If the gap between them is bigger, so it's a bit inconsistent. But if the highest minus the lower, the deviation is small, the data might be consistent. So as a hedge fund manager, do you want a bank that will be consistent, that will give you, if they promise 60%, they'll give you the 6%? Or do you want the bank that will give you 15 and next year give you 3%? So making those decisions also will depend on individual. But we know that this hedge fund manager wants to avoid risk. Okay. Now, the standard deviation. The standard deviation is widely used in statistics. It measures the spread. It is based on all values in the data. So it is sensitive to the presence of outliers in the data. Are we all together? Okay. Now, let's look at the actual problem. So the standard deviation, we know it can be calculated by using this formula, but we can use our calculator. So, this implies is the actual numbers minus the mean, and you square that, and you divide by the sample size. Okay. Okay, so the standard deviation is widely used in statistics and measures the spread. So, which you use that. So to use this formula, it's better to group the data first. But we'll use our calculator. I'll show you how to use the calculator to calculate the standard deviation. So a hedge fund manager plans to invest in a certain amount, okay, for every month in one of the three funds, which they've shortlisted them, which we agreed is A, B, and C. There's three banks. The rate of returns for the last 5 years given. This is the performance. Think of this as performance for the last 5 years. And he wishes to avoid volatility, which is risk. Let's look at Bank A. To decide which bank is best, let's compare the mean return for each. So the mean is the average. So the mean will be 10 plus 6 plus 3 plus 9 plus 9. Are we all together? Divided by 5. So that gives us 7.4% to one decimal place. So the average performance of Bank A is 7.4% in the past 5 years. Now let's look at the second bank. So Bank B, we calculate the average for the second bank, which is the mean. The mean will be 5 plus 10, 5, 10, 9, 8, and 5, and divided by 5, which is 37 over 5, which gave us 7.4. Interesting. Bank A and Bank B, the average in the past 5 years is the same. Does it mean it doesn't matter which one I choose? Or we must explore more? Okay? Okay, let's see. Let's look at Bank C. Bank C, which is 6 plus 7 plus 6 plus 7 plus 15. If we calculate the mean give us, if we add everything, give us 41. 41 over 5, which is 8.2%. Interesting. The first two banks give us 7.4%, and Bank C gave us 8.2%. So let's look at the mean. So this is Bank A, B, C. What do you choose if you calculate the mean? You say, oh, I want more money. I will go with 8.2%. It doesn't matter whether you choose A or B. The mean return for the past 5 years is 7.4%. What would you go with? Let's explore. This tells us, on average, Bank C will give a higher return. That's it. It will give a higher return. But remember, it's average. Doesn't mean exactly will give us 8.2%. It could be lower. It could be higher. That's what average means. Even those 7.4% could be higher or lower. I think we'll need to do some more exploration and see. I'm not going to conclude based on the average. Let's go more and see what we can do. Let's compare the range. Now the range for bank A ranges maximum minus minimum. The maximum for A is 10 and the minimum is 3, which give us 7%. B, the range, the maximum is 10 and the lowest is 5. So the range is 5%. C, the maximum is 15 and the minimum is 6. The range for C is 9. Interesting. What does that mean? If you look at this, bank C has a high range compared to bank A and B. So that means bank C not that consistent in terms of returns. The bank which is actually more consistent is bank B. Are you going to go with consistency or not? Or you want to a higher return? Then you make those kind of decisions. So it doesn't mean same data we arrive at the same decision. It will depend. What do you want? What are you trying to achieve? So based on this, the range for the return is smaller for bank B. This means bank B is more consistent or reliable in terms of performance. Are we together? Okay. Now we're going to compare the standard deviation now. Okay. So I'll say mean and standard deviation, those can be calculated using a calculator. Let's see how we can calculate the standard deviation. So I can calculate the standard deviation using my calculator. I'm going to use an example using A. So to do that, let's see. We're going to say, let me clear everything. We're going to say mode, stats, number 2, and we select var 1. Then we insert the data, which is 10. We're going to put bank A, which is 10, equal 6, 3, equal, then 9, equal, then what? Another 9 again, equal. Then we're going to say AC, shift 1. Then we're going to go var, which is 5, equal. Then we're going to select 4, which is equal. That is our standard deviation. That's how we calculate the standard deviation. Now let's see. So the standard deviation for bank A is 2.88. The standard deviation for bank B is 2.3. And the standard deviation for bank C is 3.83. So we have the mean, range, standard deviation. Bank C has the highest standard deviation. Remember, highest standard deviation will mean risk. So based on the hedge fund manager, because he wants to avoid risk, the bank with the lowest standard deviation is B. You'll have to go with B because you're trying to avoid risk. Okay, now let's see what we can say from that. So what does this mean? A high return standard deviation highlights that the bank risk is high and the return is more volatile in its nature and such unstable as well, which is actually bank C. Hence bank C is higher risk and bank B is lower. Okay. Now we can represent this. It's a standard deviation return, which is the average. See what we get. What does that mean? So it implies C. Can you see there? C is actually higher risk. Okay. So the bank which is actually better, lower risk will be that. between A and B, I wouldn't take A because they give the same return. Okay, they give the same return, but B, it's lower risk. Are we together? So this is what we have in summary. So actually, bank B is the best that the hedge fund manager must take. Okay, because A and B, same return, but B is lower risk. Why you want to take A? Okay. Great, guys. I hope you enjoyed, and we hope to see you soon. And have fantastic time and keep working hard. Cheers from us.